taping. Apparently there are a few people that have been absent the last few days and they have relied on. So thank you. Right?
Oh.
You got lost again?
No, I my name.
So was this from like last week? Third hour today? Third hour today?
When your teacher hands you a slip of paper
Question
and
from
calls it a late
homework.
pass.
Where do we start? 64? Yep. I know you'll find this hard to believe.
He's done it every day.
Problem today.
Oh, my hand hurts.
Susan's coming to our class on Monday.
Okay, I swore to myself that I wasn't going to use the bathroom this period.
It happens every Friday. Why is it a thing?
Because Friday I get Dr. Pepper. And I finish the bottle in a period.
Okay, ladies and gentlemen, join us please. I'm tired. I'm sure you're tired.
Exhausted.
Pick a color.
Let's do what we got to do and get through it as quickly and as well as we can. Question number 64 is right here. The thing that we have not talked about yet is bearing. So, although I do believe that you can probably look at that and kind of figure out what it is that this bearing thing is all about. It is direction, but it's actually not direction. It's bearing. And those are kind of two different things. So,
Picks green.
but it is talking about the direction that you go. North 33 degrees west. It will always start with north or south. You're either going more up or more down. So if it starts with the north, then obviously you're going more up. Okay? And then from there, that's how many degrees from north in that direction. So we're going north, but we're going 33 degrees west of north. So probably something like that. Is that reasonable? Where this angle right here is 33 degrees. Well, that makes sense logically, doesn't it?
Yeah.
Okay. 6 miles. Then makes a right-hand turn, 90-degree right. And it goes for 10 miles. Right? Might as well complete the triangle. Appreciate that. There's our triangle. Is this a right triangle?
Yes.
Yes, it is. Where's the right angle?
6 and 10.
Here?
Yeah.
There's our right angle. Triangle is drawn. The rest of the problem is easy. Forget it. No, I'm just kidding. What are we trying to find?
So the angle from the bearing that you use, basically, you're going to want to find that both the side that we don't use.
We want that angle?
We want part of that.
Oh, well,
Yeah.
but we have to find that.
Yeah, you're right.
We have to find this angle. Once we find this angle, we'll be okay. What about this side?
8.
I appreciate that thought. Here is the question.
Is that the hypotenuse?
Is that the hypotenuse?
Yeah.
I heard some no's and some yeses. How do we determine whether it is the hypotenuse?
It's across from the right angle.
It's across from the right angle. That's the key. Okay? Because sometimes it'll look like the longest side, it might not, and we don't really know. If in doubt, look to the right angle, directly across from that is the hypotenuse. So tell me about the length of the hypotenuse. I'm going to tell you the actual answer. I don't care. Because what are we looking for?
Not the hypotenuse.
We're looking for the angle. That's all we care about here. So you could find the hypotenuse, but we don't need to. So, what do? Tan. Because remember, this is the hypotenuse, we're not talking about the hypotenuse. So the tangent of theta is equal to
Opposite over
10 over 6. What do we do now?
The tan to the negative.
Yep. What angle? That's a tangent of 10 over 6. Remember, as soon as we start with what angle, what does that mean for our calculator?
inverse.
Second. So second tan 10 over 6. I'm going to take a wild guess here and say that is approximately 59 degrees.
Wow.
It's pretty impressive, isn't it? Man, I can process that and just do, or it could be the third time I've done this problem today.
Could be.
I'm not sure which one it is. Yeah, let's go with that. So, the answer is 59 degrees, correct?
Correct.
No, why not?
That's the whole angle.
That's the whole angle. We don't want to know the whole angle.
Subtract it from 33. Subtract it from 33.
We want this part of the angle,
Subtract it from 33.
which means that that is 26 degrees. So, the direction, let me rephrase, the bearing the traffic controller will use to locate the plane is north, right?
26 degrees.
26 degrees east. You got it. Okay. Never eat
Soggy waffles.
watermelon.
Waffles. Don't eat worms, period. Doesn't matter if it's...
Never eat worms in general.
Never eat soggy waffles.
I constantly eat soggy ones.
Questions,
What are
sir?
you talking about?
Why are you confused? The what?
I was seriously arguing about eating
Right.
soggy worms.
Any others? We created quite a bit of representation in the assembly today. Nice job. Nice job. Nice job. Nice job.
Oh, is it because it's in that
It's up as opposed to down, so it's north. And then it's right of north, so it's east. Sorry, I thought you had that before. All right, any others? Okay. What is the approximate measure of that angle?
We don't know.
We don't know. Good answer. X. We do care. Do we know now?
Yeah,
Can we guess?
less than 1 degree.
What's the thing? The thing in geometry you do like the protractor and like the little. What's the little thing that?
I just asked for approximate.
I think it's less than 45. So have you
Here's the note.
40.
Yeah. 45. No, it's not 45.
I would say that anything between 30 and 45 would be okay, but can we say 40 for now?
Yeah.
Okay.
No, we can't.
It's not 50. That would imply that it's greater than 45. And I think it's less than 45. Can you tell me the degree measure of that angle? If the first angle is 40, what's the second angle? Negative what? Negative 320?
Yeah.
Does it have to be negative?
Yes.
Yes, it does because clockwise. Good. Okay. Those two angles are,
Supplementary.
No.
No.
I don't know.
Wait. Oh, wait, no. Oh, they are terminals.
you're close,
Co-terminal?
coterminal.
Yeah, got it.
Those two angles are coterminal because they have
Same initial and terminal
same
sides.
initial side
Oh.
and the same terminal side. That is correct. Those two angles differ by how many degrees? 360 degrees. Because they're coterminal. And all coterminal angles differ by 360 degrees or a multiple of 360 degrees. Okay there?
Yep.
All right. This angle, either way we write it, is said to be in standard position. An angle is in standard position when the initial side is on the positive x-axis. When the initial side is on the positive x-axis. Okay? Once again, an angle is in standard position when its initial side is on the positive x-axis. What's another way of saying the positive x-axis? Pointing to the right? Yep, that'd be fine. If the initial side is pointing to the right. Short quizzes are fine. Let's see. Just out of 5, yeah, and 4 and up. Okay, so an angle is in standard position if its initial side is on the positive x-axis. For the rest of today, every angle that we talk about will be in standard position. For the most part, for the rest of this chapter, the angles will all be in standard position. Okay, so that is something that we will deal with a lot. So, this angle, which is in standard position, can you give me the approximate degree measure of that angle if it's a positive angle?
101.
95, 100?
101.
Okay, somewhere in there? Yeah, I understand, because it could go around 1.5, more than a time and stuff like that. So that's fair. That was, but in this case, I was looking for, what'd you say, 95? Somebody said 100.
101.
Could I say 85?
No.
Why not?
It's more than 90 degrees.
It's up to sir.
Okay.
I'm too sir.
Bless you. We're going to start merging a few things that you've learned over the past few years, which is why you do trig after you've done algebra and geometry, because it kind of incorporates the two. So let's say we have an angle in standard position. And what we're going to talk about now is which quadrant the terminal side is in. So in our first one, our terminal side would be in quadrant 1. In our second one, the terminal side would be in quadrant 2. What is the separating point between quadrant 1 and quadrant 2?
The y-axis.
Which, as a degree measure, would be 90 degrees. Does anybody see a red marker around?
There's like a purplish one.
Yeah, I know. Where? That's not right. I want red. Can you go back there? All right, so the
I told myself no.
borderline
We knew it wasn't
between
going to
first and
happen.
second quadrants
But we wanted to pretend it was.
is, what'd you say, 90 degrees? Okay.
Today's what, 22nd? It is not 2014. Just try to convince myself it was 2014.
I drew 2016 on my paper the other day.
I didn't draw this well. See, I didn't draw like this back in 2014. In 2014, this was like the best thing you got out of me, maybe. And it wasn't even that good.
Yeah, that's literally me.
90 degrees. What is the borderline between the second quadrant and the third quadrant? 180 degrees. What about between third and fourth? 270 degrees. And then back to the end, which would be
360.
360 degrees. Or we could say 0 degrees. Is that fair? Yeah. All right, so you're going to be asked some questions at some point on your homework where they start to ask if an angle is in terminal, or if an angle is in standard position, what quadrant will the terminal side be in if the measure of the angle is 243 degrees? The answer would be quadrant 3, and you can tell simply by the angle measure. Yeah, if the angle measure is, it's that whole 90, 180, 270, 360 thing. Okay? All right, cool. Let's see where I gotta go with this. So we will talk all the time about angles being in standard position. Okay. So let's say that we get an angle, or they talk about an angle in standard position, and most likely I'm going to just stop saying an angle in standard position because all of our angles will be in standard position. Okay. So let's say that we have an angle, and they tell us that the terminal side of the angle goes through the point 4, 3. So we have an angle in standard position whose terminal side goes through the point 4, 3. Fair for me to call that theta? Yeah, that's fair. I want to know what are the values of the 6 trig functions of theta? Wow. Say what?
Draw a triangle.
Draw a triangle. From where? From the point.
To the axis.
Which axis? Always the x-axis. We will draw triangles all the time because it makes it easier for us. And the triangles will always go to the x-axis. Never to the y-axis. Y-axis is bad. Everything here goes to the x-axis, okay? And there is our triangle. What's the length of this side? 4. How do you know that?
That means we ran.
That's 4. What's the length of this side?
3.
3. What's the length of this side?
5.
How'd you get 5?
3, 4, 5.
Pythagorean triple. If it was not a 3, 4, 5, what would you do to find the third?
Pythagorean theorem.
Pythagorean theorem. Good. Pythagorean theorem to find the third. Okay. Oh. Well, can we find the sine of theta now?
Yes, sir.
What's the sine of theta? Is what? I'm sorry? 3 over 5. Cosine of theta? 4 over 5. Tangent of theta? Opposite over adjacent? 3 over 4. Cosecant of theta? 5 over 3. Secant of theta? 5 over 4. Cotangent of theta? 4 over 3. Yep, cool. So that problem ended up being a little bit easier than we thought. Yeah? Once we drew the triangle. Once we see a triangle, hopefully the world gets easier at this point. So draw the triangle, draw the triangle, draw the triangle. All right, change up this problem a little bit. Why? Because I can. God bless you. I no longer want this point to be 4 comma 3. That's what I want to do. X comma y. So we're getting the more generic version here. So what's the length of this side? X. It's the same triangle, right? So that side is X, this side is Y. What's the length of this side?
X squared plus y squared.
X squared plus Y
The
squared.
square root of x squared.
The what?
The square root
The square root of that, right? Because X squared plus Y squared is equal to C squared, but then we would need to take the square root of it, right? So the hypotenuse is the square root of X squared plus Y squared. No, we cannot take the square root of things that are being added and subtracted. Remember that whole, did this towards the beginning of the year? We said, is that true? No, but if you took the square root of 4, God bless you, if you took the square root of 4 and you took the square root of 9, right?
Yeah.
So that's why we can't do that. All right. For reasons that you will see in the next 10 minutes or so, we're actually going to call the hypotenuse, the square root of x squared plus y squared, we're going to call that r. We're going to call that r. What does r usually stand for in things?
Radius.
Yippers.
Circle time.
Yeah, we're going to start. So we're going to be merging trig and triangles with coordinate planes and circles.
I already have a
All in
headache.
the same problem. It is truly awesome
The
stuff.
happiest I've seen you look
Don't say wait. I'm already waiting.
all day today.
Have I heard of the concept of proportionality? Constant of proportion. Constant variation.
Do they use K for it?
This is.
Circles are the worst.
Okay, let me run. Here we go. If we are using this generic version,
No. The viewers can know that you did this
what's
to
the
them.
sign of theta?
Y over R.
Y over r. What's the cosine of theta?
X over R.
X over r. What's the tangent of theta? Y over x. And you can find the other three. But for right now, I care about those. Huh. So, will that work for any x and y?
Yeah.
Yes. This is the generic version. This will work for any x and y. R is equal to square root of x squared plus y squared. This you are going to want to remember. Okay. Sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x.
So
Yep, exactly.
X always has to be the mother. Like you can't flip flop.
That's why we always go to the x-axis. We always want to draw it to the x-axis so we get a triangle that looks like this. Let's say that we went to a point over here. Okay, and we were talking about that angle. Well, we're still going to go down here, and we're still going to have x and y and r. We'll still have the same thing. We'll always go to the x-axis. I'll explain that angle thing, I guess, Wednesday.
Our test.
The test is going to be Tuesday now. Test is Tuesday now. Yep. All right. Doing okay so far?
Yeah.
All right. Let's, as long as we don't have to do Oops, is that what you said?
Yeah.
Love that.
For now.
It's not so much fun.
Okay. So, here's a question we're going to be asked on our homework. The question says something along these lines. Calculate the values for the 6 trig functions of theta in standard position. If the terminal side of theta lies on y equals 3x. Ooh, that sounds fairly intense. Find the 6 trig functions of theta if the terminal side of theta is on y equals 3x. Okay. Well, I know that the initial side is like that. Fair?
Because X is.
So what do we do now? Draw a line. What line? Y equals 3x. That's a good idea. How do we draw y equals 3x?
Point on 3.
Going up 3.
From where? Why the origin?
Because that's the y-intercept is 0.
Y equals 3x is in slope-intercept form, right? Y-intercept of
0.
0, slope of
3.
3. So we could go
Up 3 or 1.
up 3, right 1. We doing okay so far? Okay. But because another way of phrasing this is x is positive. X is positive. Then we can what? We can zap this part. Does that look more like the angles we've been using? Yeah. So what do you think we do next? Draw a triangle. What point do you want to use?
1, 3.
1, 3. Makes sense, right? Draw the triangle by going straight down to the x-axis.
That's a tiny triangle.
And there's our triangle.
That's the little
Length this
sliver
side
of
is
cake.
1. Length this side is 3. Length this side is. Gotta be better than that. You guys can do this.
Square root of 10.
Alright.
Yeah, square root
1 plus 9.
10. Yeah, square root of 10.
Square root of it.
Huh, I was right.
We did Pythagorean theorem, or we use this r equals square root of x squared plus y squared. Either way, we get square root of 10. Fair?
Fair.
That's always true. What's the sign of theta? 3 over square root of 10, which will make 3 root 10 over 10. And now we have everything we need. We could just keep going and do cosine and tangent and secant and cosecant, all that. We okay there? Does that make sense? What if somebody said, I don't want to use 3, 1, or well, I'm sorry, you did this to me. I don't want to use 1, 3. I want to use 2, 6. Now here's our new triangle. Length of this side is 2. Length of this side is 6. Length of this side is. Nope. Now we're getting better. Square root of 40?
Yeah.
Yeah.
36 plus 4?
2 from 10.
So square root of 40, which is 2 root 10.
Oh.
Yeah, I know. You see all that.
Increasing by 2.
What's the sine of theta?
Wait.
Same
Over
thing.
square root of
6 over
2 root
2
10.
root 10, but 2 goes into 6 3 times, which gives us 3 over root 10, which is exactly what we got there.
Wow.
So therefore, it doesn't matter which point we pick as long as it's on the line. We will always get the same sine, the same cosine, the same tangent. And that is what trig is all about. Trig is really the relationship between the length of the sides of a triangle given certain angles. Okay? The fact that this angle, and do we know the measure of this angle, by the way? I got no clue. I have no idea what this angle is. Guess what? I don't care. I don't care what this angle is, but I can tell you that whether it's the angle for the smaller black triangle or the bigger green triangle, the relationships of the sides of the triangle are still
Important.
exactly the same. Right? The relationship between the opposite side and the hypotenuse is still 3 over the square root of 10, whether we use the smaller version of the triangle or the bigger version of the triangle. And if we made a super huge version of the triangle, guess what the sign would be? The sign would be the same thing. Does that make sense? That's what trig's all about. Okay? All right. So far, so good?
So if the triangles are similar, they'd have the same sign. Okay.
Yippers.
Wait, so for the C's out,
Cosecant, yep.
how did you guys?
I would just flip that, because cosecant is the reciprocal of sine.
Alright,
And so if I'm going to do cosecant, I'm going to typically flip the original version. Less words. Can you imagine flipping this? We'd flip this, then we'd have to rationalize again, and then we'd have to cancel again, and all kinds of things. So more often than not, it's going to be easier to reciprocalize the original. Yeah, it's my new verb. Never heard of a verb coming from the word reciprocal, have you? Reciprocate, that's not bad. It's not really, I guess it is reciprocal. Yeah, but from a math taking the reciprocal of, I don't think reciprocate was right there. Anyway, okay, I'm about to draw perhaps, very likely, that's the word I wanted, very likely the worst circle you have ever seen.
Okay.
It
Wait, you can't do that one thing like everybody's like